All right, so today we're going to take a look at 2.2 part 2. So yesterday we looked at finding the 6 trig functions. Okay, we learned the definitions. The definitions are exactly the same today. And sometimes you had to find the coordinate if it landed on an axis. 0, 90, 180, or 270. Today we're going to look at what happens when we don't land on an axis and you have to find the coordinate. But it's going to be very specific angles. Okay, it's not just going to be any angle. Like what's the coordinate for 26.4 degrees? We're never going to do one like that. Only angles we look at are multiples of 30, 45, and 60 is a multiple of 30. So first, we're going to look at how do we get the coordinate for a 45-degree angle. That'll be the first one. So what I'm going to do is I'm going to draw a unit circle. I'm going to draw it to scale, and I want to just kind of look at what we think the coordinate might be. So let's take the biggest grid that I have, which is that one. All right, I'm going to put a unit circle there. Now, sometimes when I ask, what do you think the coordinate is for 45 degrees, I get like 1, 1. If you did 1, 1, would you be on the circle? No, you're off the circle. All right. So sometimes people say, well, maybe it's like 0.5, 0.5. Well, here's 0.5. Here's 0.5. If you go up 0.5, and you go over 0.5. Are you on the circle?
No.
No. So it's not 0.5, 0.5. It's a little more than that. Okay. It's about 0.7 something. So we're gonna see exactly what it is. It ends up being a square root. Okay.
Oh.
But the idea that it is two numbers that are the same, because when you're doing a 45-degree angle, 45 would be about right there. You're going to go over and you're going to go up exactly the same amount. That's what makes it a 45-degree angle. So let's take a look. I'm just going to draw the diagram a little bit bigger. Okay, so this is going to be the diagram for the 45, 45, 90. This has nothing to do with the 30 and the 60. That's a different diagram. Same diagram. You can do the same one for 30 and 60. But you need a different one for 45. Okay, so here's 0. Here's 90. So put 45 about halfway through quadrant 1. I guess another way to think about it is when you have a 45-degree angle, the slope of this line is 1. That's the slope. Slope is 1. All right, and now what we're going to do is we want to figure out the coordinate for that point. So I need to turn that into a shape. What shape do you think I'm going to end up making inside the circle? Yeah, you make a triangle. And the way I'm going to do it is I need a vertical. And I'm going to put it right there. And I got a little extra, but that's fine. I just made a triangle, which I'm going to highlight in red. Okay. How much is the angle in the lower right? Yeah, that's a 90. And this angle, by definition, is 45 degrees because the hypotenuse is pointed at a 45-degree angle. So that's 45. And what does that make the angle up at the top?
45.
Yeah, it makes that 45 degrees at the top as well. So I have that same triangle. I'm just going to draw it bigger. Let's see, over here. Actually, before I show you, one other thing. One of the sides of this triangle we already know. What side do we already...
The hypotenuse.
Why? Yeah, why do we... How come we already know the hypotenuse? It's the radius of that circle. And we already know what kind of circle it is. It's a unit circle. So what's the hypotenuse of that triangle?
1.
Yeah, it's 1. Okay, so here's the same diagram. Just a little bit bigger. Now, our goal is to figure out 2 things. First thing I need to figure out is how long is the base? That's the horizontal distance from the origin to right there. What part of the coordinate do you think that's going to be?
The x.
That's the x. It's how far right you go. And then we need to figure out how far up. What part of the coordinate do you think that is?
Y.
That's the y. So we need to find those 2 things. But when you use 2 different letters, you're kind of suggesting to somebody that they're different. This is a 45, 45, 90 triangle. What does that mean in terms of the kind of triangle it is? There's a word from geometry to describe a triangle that has 2 angles that are the same. Yeah?
Never mind.
Yeah?
Is it an isosceles triangle?
Yes, this is isosceles, which means you have 2 angles that are the same. You also have 2 sides that are the same. Which sides? The sides opposite the 2 angles that are the same. So the bottom and the height are exactly the same. If they're the same, which they are, we should use the same letter to represent them. So let's just pick one of these 2 letters and use it twice. All right, so we're going to call this x, and we're going to call that x. So whatever you solve for the base, it's exactly the same for the height. All right. So we have one side, and we need to find the other 2, but they're the same. There's a theorem you can use in a right triangle that connects all the sides in a way that you can figure them out. Does anybody know the theorem?
The Pythagorean.
Yep, the Pythagorean theorem. So we can use the Pythagorean theorem, and we can solve for x. Does anyone think they could set up the Pythagorean theorem for me with those 3 things I just circled? Yep.
A squared plus b. X1 squared plus x2 squared.
And they're both the same thing, so we're just going to call them x.
X. Okay.
Yeah, so x squared plus x squared
Equals 1.
1 squared, which is just 1. Okay, what's x squared plus x squared?
2x squared.
2x squared. Yep. And now we got to get the x squared by itself, so we got to get rid of that 2.
Divide by 2 on both sides.
Divide by 2 on both sides. So that's gone. And now we have x squared equals a half.
Take the square root of both sides.
Yeah, take the square root of both sides. Square root. Square root. What's the square root of x squared?
X.
Yes, now we have x by itself. When you take the square root of a fraction, you do the top and the bottom separate. So square root of 1 over square root of 2. Well, the top is okay. What's the square root of 1?
Plus 1.
It's 1. But when we look at the bottom, we can't take the square root of 2. We get a number we can't. It's not a perfect square. So how are we going to fix having that square root in the bottom?
Multiply it by square root of 2 over square root of 2.
Square root of 2 over square root of 2. And what is that going to give me in the bottom now?
2.
2. And what about in the top?
Square root of 2.
Square root of 2. So hopefully that's a number that looks a little familiar. That we've seen square root of 2 over 2 before.
I have a question. Where did the square root go in the 1/2 after you divide it? Oh, wait, never mind. Divided by 2, yeah. That doesn't make sense to me.
So when you square root a fraction, it goes to both the numerator and the denominator.
No. I'm talking like before that. Except before that, we divided by 2 on both sides.
So we had 2x squared equals 1, and then we did divide by 2 and divide
Yeah,
by
where'd
2.
where'd the square root go? Or what's going on here? Am I just not seeing what's going on?
So we had
Yes.
this.
Yeah, the one. No, like you had 1 squared before that, and now you just have half.
Oh, well, 1
Because
squared is
one
just
squared
1.
is 1. 1 squared is 1.
Oh.
And then you just divided 2 by both sides.
See, told you I was missing something.
If that was a number like
Yeah.
3, I would have done, 3 squared.
you would have
equals
done it
1.
out. Alright. I was just saying, I knew I was missing something, it just
Yep.
didn't click right away.
All right, so now this, that's what x equals. It's the square root of 2 over 2.
So that's also 1.
So yeah, this side is square root of 2 over 2 from here to here. And this side is square root of 2 over 2 from here to there. So now we know the length of the bottom and we know the height. So let's write the coordinate. What is the length of the bottom to get from here over to here?
Square root of 2 over 2.
Square root of 2 over 2. And what's the height to get from here up to our coordinate on the circle?
Square root of 2 over 2.
It's also square root of 2 over 2. Now that we know the coordinate for 45 degrees is that, we don't have to figure that out again. Okay. If we had to, we could use Pythagorean theorem and do it. But the idea now is just to remember that that is the coordinate. Or put it on your reference sheet. Yes?
Are we ever not going to be using a unit circle?
I'll have to see tomorrow if we do one problem without a unit circle, but it's very, very similar. It's not really any harder as long as you know how to do this. Yeah. So now that's 45 degrees. I don't want to get into it a lot today, but 135 is right here. Anybody have a guess what the coordinate for 135 is?
Negative square root of 2 square root.
Yeah, it's negative square root 2 over 2, comma, square root 2 over 2. So once you know the coordinate for 45 degrees, you can mirror image that into any quadrant to find any 45. The only difference is sometimes the first one is negative, the second one is negative, or both of them are negative. But in quadrant 1, they are both positive. All right, so question on the 45, 45, 90. Okay, so we got that coordinate. Now, let's see if we can find the 6 trig functions of 45 degrees. So, if that's what they gave you, find the 6 trig functions of 45 degrees. What's the first thing that you have to figure out? Yeah, you need the coordinate. You can't do any of these without the coordinate for 45 degrees. So now, what's the coordinate for 45 degrees?
Square root of 2 over 2 and square root of 2 over 2.
Square root 2 over 2, square root 2 over 2. And I think we did that problem in the notes yesterday. Okay, it's probably might be example 2 from yesterday. But we can go through it again. So the only difference today is you didn't know that coordinate. It wasn't given to you. You had to find it. But now we found it. Okay. So x and y. Okay. What's going to be the sine of 45 degrees? Yeah.
Square root of 2 over 2.
Yep. And which one did you pick?
Y.
Yep, it's the y. If you mix the x and the y up with 45 degrees, you'd be lucky because they are the same. But most of the time, they're not the same. All right, so square root 2 over 2. What's my cosine?
Square root 2 over 2.
It's also square root 2 over 2, but this time it's the x. All right. What about the tangent?
Just 1. It's just 2, right? Or square root of 2.
Just 1.
Well, you're going to divide the y by the x.
Yeah.
and the y and the x are the same.
Oh, right.
So it's just one.
1. So we could do the cotangent pretty quick. When you flip 1, you get 1. That's 1. And to get the cosecant, we have to flip the y, which is which trig function? Well, when you flip the y, that's how you get cosecant. But which trig function are you flipping? Yeah, you're flipping the sign. So when you flip it, what do you get at first? So you get 2 over the square root of 2.
2 square roots of 2 over 2, which
So-
would just be square root of 2.
It would just be square root of 2. So when you fix it and get rid of the root in the bottom, it's just square root of 2. Any question on how we fix that? So we just get square root of 2. And what about the secant?
Square root is the same thing.
Yeah, because the sine and the cosine are the same. So are these two. And that's how you find the 6 trig functions for 45 degrees. Any question on that? Okay, so that's the 45. Now we're going to look at the 30 and the 60. We can pretty much use the same diagram for both to figure out the coordinate for 30 and the coordinate for 60. I'm going to do the coordinate for 30 first. So 30, it's about a third of the way through the quadrant. Like if you think of 30, 60, 90. It's 1/3 of the way. So basically just make it look like it's less than half. You do have to draw it somewhat in the right spot because we're going to use our sketch to figure something out. Okay, and what shape are we going to make in our triangle? Yep, we're going to make a triangle. So draw your line from your 30-degree mark on the circle to the origin. Okay, and then you need a vertical. Right there. Okay, so here is the triangle we're going to look at. Same goal as last time. You need to figure out how long it is from here to here. That's going to be the x. And then from here up to there. And what's that going to be?
Y.
That's going to be the y. Now this time, are the x and the y going to be the same?
No.
No, this is a scaling triangle. Okay, all the angles are different. So we got the 90 in the lower right. We got the 30. That's right near the origin. And that's because the hypotenuse is pointed at 30 degrees, so it has to be a 30. And then why does it have to be a 60 at the top?
Because the other one's 90.
Because the other one's 90, and they all have to add up to what?
180.
Right. They all have to add up to 180. So that's the same triangle. I just drew it a little bit bigger so we have more space. All right. We need all 3 sides, but is there any side we already know?
The hypotenuse?
Yeah. What's the hypotenuse?
1.
1. It's still the radius of the circle. Now, unfortunately, that's the least useful side because what we really need is the base and the height. Okay. If we did Pythagorean theorem this time, could we use the same letter twice? Or would we have to use different letters?
Different letters.
Yeah, and the problem with different letters is now you have 2 variables, and that's not going to work. So we can use Pythagorean theorem, but you got to figure out one of those other sides a different way first, without Pythagorean theorem. And I'm going to give you a hint at how you could do it. And we'll see if my hint is enough for you to figure it out. Let's make a copy of that. That's my hint at how you can figure out one of the other sides. Anybody have an idea what to do? Yep.
Double it.
What do you mean double?
Times 2.
So what are you going to do with that other triangle?
So like 2x squared plus 2y squared equals.
All right, let me ask you a different way. Where are you going to put this triangle? You have to do something with it.
Are you gonna flip it and make it a rectangle?
You want to flip it and make it a rectangle. So you would have to flip it like that to do that. Actually, no, you'd have to flip it both ways, wouldn't you? Yeah. All right, so yeah, you could do that. That's it's definitely a rectangle. Yep, I agree. That's a rectangle. Now what would we do? I hope you know, because I don't. Not with that. Yeah, so you could make it a rectangle, but I'm not really sure what we would do from there. Anybody have another thought?
They can tap the triangle by
Okay.
flipping it so that the two short sides are up against each other.
We could make the two
Then
short
you-
sides up against each other.
90 would become a one. The 90 degree would be a 180. You'd have two 30s, and then you'll have 60 times 2 would be 120 at the top.
Okay, I think everything you said was correct. But instead of positioning it so the two short sides are against each other, I want to position it a different way. What's another way I could make a triangle?
Two long sides and then one isosceles.
All right, let's put these two together. So, what do we have now?
An equilateral triangle.
An equilateral, and what does that mean?
All sides are length the same.
Right, so that side's 1, that side's 1, and this side is 1. Okay? But what else do we know? The goal is to find the length of one of the sides in the original triangle I had.
That means
So
half
they're
is
y is one half.
Right, the y has to be a half because this is a mirror image of the top one. So I know these two sides are the same length. If they're the same length and they give you a total of 1, they each have to be 1/2. Okay, we don't need the bottom triangle anymore because now we figured out the y without Pythagorean theorem. Now you know 2 of the sides. You can use Pythagorean theorem to get the third. Okay, so I'm just going to move that out of the way. And let's call the bottom side x. Okay. And how would we set up Pythagorean theorem?
x squared.
Those.
X squared plus
X squared plus 1/2 equals 1.
Yep, equals 1 squared. Okay, so we'll do that out. X squared. What's 1/2 squared? 1/4. And how are we going to get the 1/4 on the other side? Subtract it. What's 1 minus 1/4? 3/4. And our last step,
get rid of the square root.
get rid of squaring by taking
Taking the square root.
the square root. And remember, when you square root the fraction, do the top and do the bottom separate. Can you simplify the square root of 3? Nope, that's fine, but it's in the top. That doesn't matter. Can you simplify the square root of 4? Yeah, what is it? 2. There's the length of the bottom side. So in a 30, 60, 90, the big side in the triangle, not the hypotenuse, but the big length, is square root 3/2. And the short side is always a half. So what would be the coordinate for 30 degrees?
Square root 3/2 and 1/2.
So square root 3 over 2, comma, 1/2. That's the coordinate for 30 degrees. And that never changes on the unit circle. Okay, so we don't want to have to go back and figure that out again. Now we know it. That's the coordinate. Now, 60, you don't have to do any of that all over again. You have everything you need to figure out 60. 60 is right there.
60 just the inverse.
So what's the difference between the 30 and the 60?
The X and Y swap.
Yeah, the x and the y are swapped. Instead of the short side going up and down, now the short side goes left and right. And instead of the long side going left and right, now the long side is up and down. So all you have to do is remember how long is the short side and how long is the long side. The short side is x. What's the short side? 1/2. Short side is always 1/2. And the long side?
Square root of 3 over 2.
Yep. Square root 3 over 2. Perfect. So when you're dealing with the 30 and the 60, the two numbers you have to remember are 1/2 and square root 3 over 2. You have to get them in the right order, but those are the numbers you have to remember. When you're dealing with the 45, 45, 90, the only number you have to remember is root 2 over 2. So it's three numbers that come up. Root 2 over 2, root 3 over 2, and 1/2. Those are the only three numbers that come up when we do unit circle trick. In a quad, like this. So any question on those two coordinates? All right, so let's try to find the 6 trig functions of pi over 6. If you're not sure what pi over 6 is, what could you do first?
Convert it to degrees.
Yeah, you could convert it to degrees. If you know what it is, you don't have to do that. The whole goal, you need the coordinate. So however you can figure out the coordinate for pi over 6, that's what you need. And what's 180 divided by 6?
300.
30. Okay, so this is a problem about the 30-degree angle. And now let's see if we can remember the coordinate. What are the two numbers that come up when you're dealing with a 30-degree angle? You don't have to tell me in the right order, just the two numbers. 1/2 and
Square root of 3.
square root of 3 over 2. I can figure out what order they go in by drawing it. If I draw my circle, is 30 in the middle closer to the x-axis or closer to the y-axis?
Closer to the
Yeah.
x-axis.
It's closer to the x. If you draw it somewhat reasonable, it should look like you have a long side and a short side. This is the long side. This is the short side. In the 30, 60, 90, that's the 30. The blue side is the short side. How long is the short side? 1/2. That's always the 1/2. And how about the long side?
Square root of 2.
Yeah, that's always square root 3 over 2. And that's because the square root 3 over 2 is a bigger number than 1/2. This is 0.5. That's about 0.86. So the bigger side gets the bigger number. Small side gets the smaller.
If you'd have put that as a coordinate, just making sure it'd be 3 over 2, then 1/2.
Root 3 over 2,
Yeah.
comma 1/2.
Okay.
Yep.
And then 60 would just be the opposite.
Yep. So that's our coordinate. Now it's no different than what we did yesterday. Find all 6 trig functions. Okay, so what I would ask you for on the test, 2 things. I would say First, I wouldn't give you all 6 of these in the same problem. Okay, I'd only give you one of the 6. And I would say, for example, find the sine of pi over 6 and tell me the coordinate that you use to do it. Those are the 2 things I would ask. So there's your coordinate, root 3 over 2, 1/2. And now, what is the sine? It's the y value, which is 1/2. Okay. What's the cosine?
Square root of 3 over 2.
Square root of 3 over 2. And the formula for tangent?
Y over x.
Y over x. And if you just kind of imagine doing this, imagine putting a division line right there. That's your y. That's your x. You're dividing the 2 of them. When you divide them, what cancels out? Yeah, you have the same denominator in both. So what are you left with at the top?
1 over square root of 3.
1 over the square root of 3. And when you fix it, what do you get?
Square root of 3 over 3.
Square root of 3 over 3. Perfect. Now, let's do the cotangent just because we're right here. This is the same kind of deal. You could either flip what's in that red box, or you could flip what's in the black circle. They're equal. They're the same thing. We did this before. Which one should you flip?
The one with the red box,
Yeah, how come?
because it would flip the square root on top.
Yep. If you flip that, you're done. If you flip the black circle, the root goes back to the bottom. Now you got to fix it all over again. So that is square root of 3. How about my cosecant?
2.
That's going to be 2. It's always nice when there isn't a root. It's easier to flip. And how about my secant?
2 over square root of 3.
So we can start with 2 over the square root of 3. And when we fix it,
2 times the square root of 3 over 3.
2 times the square root of 3 over 3. Perfect. And yeah, you do have to fix it. You got to get rid of that root in the bottom. Okay, so there's your 6 trig functions for 30. Any questions on that? All right, so I'll leave that one up. And I'm going to have you guys try the 6 trig functions of 60. And then once you get all your answers, I want you to kind of look at how the answers you get for 60 compare to the answers you get for 30. I think you're going to notice something.
Before I even try, can I make a rough guesstimate?
Sure.
Is it going to be the sin, cos, and tan will be on the other side? It'll just be on.
They're
Everything's
not
gonna be
all
flipped.
going to flip left to right. No.
No.
Not completely.
The sine and cosine are going to be flipped.
The sine and cosine are going to flip. Yep.
Tangent is going to be flipped.
The tangent is going to flip with which one?
With cotangent.
With the cotangent. And what's the last ones that are going to flip?
CSC and the SEC are going to flip.
Yep, secant and the cosecant.
I was kind of putting that with the cosine.
Now, I'm not sure if I mentioned it, but when you put co in front of a trig function, like when you say sine and then you say cosine, the co stands for complement.
Yeah.
So sine is, cosine really means the complement of the sine.
So the complement of y is x.
Well, the complement, like when you talk about complementary angles,
Yeah.
those are angles that add up to what? That's supplementary.
90.
90, yes.
Oh.
So cotangent is the tangent of the complement of the angle. That's what co really means. It means complement. We'll talk more about that in the next section, next week. So, but I kind of came up right now, so I just wanted to mention it. All right, so see if you can get your six trig functions. Okay, so we're finding the 6 trig functions for 60 degrees. What's the first thing that we need to know about 60? Its coordinates. We need its coordinate. Now the 60, if you think about that, that's higher up in the circle. So when you make the triangle, it makes the short side the base, and it makes the tall side the height. Okay. So what did you guys get for the coordinate for 60?
1/2 square root of 3.
Yeah, 1/2 square root 3 over 2. And now we can fill them all in. Okay. What, Isaiah, what's the sign?
Square root of 3.
Yep, square root 3 over 2. Alex, what's the cosine? Right, what's the formula for cosine? Do you remember that from yesterday? Is the x. And the x is 1/2. Okay, and tangent? Alex, what's our formula for tangent?
Square root 3.
All right, yeah, it's going to be square root 3 because you're just going to imagine dividing these two. The 2's are going to cancel, and you're left with square root 3 over 1, which is just square root 3. Okay, how about my cosecant? Yeah?
Times the square root of, can I say?
Yeah.
2 times the square root of 3 over 3.
2 times the square root of 3 over 3. Perfect. How about the secant? Yeah, 2. It's going to be 2, because when you flip a half, you get 2. Now we have to flip this one. It's not a fraction, but if you want to think of it as a fraction, just put a 1 under it. Okay, what do we get when we flip the square root of 3? Yep.
Square root of 3 over 3.
Yep. Square root of 3 over 3. That's when you flip it and you fix it. And now if you look at what switched places, the sine flipped with what we call its co-function. The sine and the cosine. The secant and the cosecant. And the tangent and the complement of tangent. Or we call that cotangent. Okay, that's what the co stands for. Complement. And that's how you do the 6 trig functions for 60. So any questions on that? All right, so the homework, that is a worksheet. I think there's 10 questions on the worksheet. And then there's 5 questions from the board. Okay, but the other 10 questions are on a worksheet. It says 2.2 part 2. And that's on Schoology.
Can you see a picture of this real quick?
Yeah.
Can I see a picture?
Yes. Sure. Thank you, guys. A couple of quick reminders.
Just in case.
I will be here after school on Thursday if you need any help. We have a test on Friday, first test for term 3, and you'll be getting your report cards later. I would say probably Thursday or Friday night periods. You'll probably get that in this class. All right, so you've got about 20 minutes or so. So you can use the time to try to start the homework, but please try to get something done with the 20 minutes you have. Yes.